class. Okay, here we go. All right. So my name is Alice Musafatiki. I am the clean room manager, lab manager, and everything else in between. This is usually a two-session class. Start off one day with general lab safety, and then go on the next day and do the clean room chemical safety training. So today it's gonna be combined salad mixture. So we will have fun with it. So before we go into the clean room portion of it, I'm going to talk a little bit about the general safety part of it, the general chem, for those that have not been into a chemical lab or into any kind of lab that processes chemicals that you might need to know about. First and foremost, if you are going to be working with chemicals, let's say you're going to be working with hydrochloric acid and you have never worked with hydrochloric acid before, you need to pull out the safety data sheet. You can pull those out online if you just type in Google search um, hydrochloric acid, you will find an SDS for it, safety data sheet for it. Make sure you read that thoroughly because it will give you a lot of information that you need in order to stay safe. For example, it will tell you if you spill it on yourself, what do you need to do? Do you need to work with a mask on? Do you need to work with gloves on? Do you need to work with it under the hood? All that kind of information. How do you safely transport it from this cabinet to your workbench? And what do you do with the leftovers? Because with any chemicals, if you pull out 5 mils from a 70-liter gallon, 70-liter jar, and only use 2 mils, you cannot retain the leftovers into the main jar. You have to dispose of that. So all that information is contained on how to safely dispose of it. You just don't throw things down the sink. So safety data sheets, usually they will give you information about that, the chemical properties of that, the exposure, the toxic effects if you are exposed to it, storage and handling. In case of emergency, it will tell you what to do. So talking about, have it in a beaker. Always, whenever you are in a lab, label your vessels. I cannot stress that enough for anybody that has been in the laboratory to always label your vessels. There's no visual difference between 3 mils of hydrochloric acid and 3 mils of nitric acid, both in 25 mil beakers. If they are sitting side by side, you would not know which one is which one. So always make sure when you put something in a vessel, label that vessel. That will go a long way in your future as laboratory people. Also, the other thing you would want to do is always make sure that before you start doing your work, you have to know what kind of safety gear you need. Do you need safety glasses? Do you need gloves? And if you need gloves, what kind of gloves do you need? Because there are different kinds of gloves for different applications. So some of this stuff I'll be coming back to it, and hopefully it will make sense for some of you that have not been in the laboratory before. So today we are going to talk about what is a clean room. We're going to talk a little bit about clean rooms. What is a clean room? So a clean room is a controlled environment. But what is a controlled environment? A controlled environment is a space where environmental parameters are monitored. For example, you monitor temperature, you can monitor humidity, you can monitor pressure, You can monitor particle count, noise, vibration, electrostatic discharge, etc. All those things that will affect your environment, you have to figure out which ones that you want to monitor, and that's a controlled environment. So clean rooms are types of controlled environments. So you don't just build a clean room because you want to build a clean room. First, you have to identify what it is that you are doing, that you want to do in the clean room. What kind of processes are you going to do before you decide to build a clean room? And then you have to identify what are the problems that you are going to encounter in order to achieve your goals. So if particles are going to be detrimental to your processes, then you have to build a clean room that will address those problems. And if particles are the problems, then you also have to figure out what size particles are going to be problems for your environment. So clean rooms are constructed to minimize the introduction, generation, and retention of contaminants. And your contaminants can be anything from temperature, humidity, pressure, particle count, electrostatic discharge, and all those things. So our clean room is a microelectronics clean room, and it's a class 100, class 1000 in the old terminology, or class 5 and 6 in the new terminology. And we monitor the temperature, humidity, pressure, and particle count in our clean room. There are different types of clean rooms, and the clean rooms are also segregated according to classes. And therefore, in order for you to maintain what it is that you set out to build, you have to have a certain clean room protocol that you're going to adhere to. Meaning that if you have a class 5 or class 6 or class 100 clean room, you have to figure out a way where you are going to minimize the introduction of those particles that are detrimental to your processes. So I talked a little bit about clean room. I talked a little bit about the types of clean rooms or classes of clean rooms. I'll go back to the types of clean rooms. You can have one big giant room with equipment that you do your processes on, and then you also have supportive equipment, like your gas cylinders, your chillers, your little pumps. All those are in one big giant room. We call that a ballroom design, where everything is in one room. We also have the bay and chase design, meaning that the clean room portion of it, where it's you are monitoring your environment, where you do your work, where you are actually doing your processes, will be in the bay, and the chase would be where all the different supportive equipment is: your gas cabinets, your gases, your chillers, your pumps, everything else that would be considered to shed particles, or everything else that would be detrimental to your processes if they are in the same environment as your process. So clean room cleanliness is based on particles. You have decided that you are going to have a microelectronics clean room, and you want you want your clean room to be a class 5 or class 100. So what does that mean? That means the particles for a class 100 or a class 5, these are the same. Class 100 is the old terminology, and class 5 is the new ISO ISO nomenclature. So in the old class 100, you would have a 1 square foot box, and in that 1 square foot box, 1 foot by 1 foot by 1 foot, you would have no more than 100 particles that are 0.5 microns or larger. And in the newer terminology, you have a 1 cubic meter box with more than 30, less than up to 3,500 um, particles in that cubic meter box. So I have a chart here that will show you the different kind of classes. So on the top one, you have your class 100, which is the old nomenclature. It's same as class 5, and you would have 0.5 micrometers particles. In that cubic meter box, you'll have 3520 particles. And in class 100, you would have 100 particles or less that are 0.5 microns. So how do we achieve the cleanliness of that space that you are designing? All particles or most particles are suspended in the air. So you have to figure out a way of getting rid of the particles, which is through airflow. You have in this picture that you are seeing right here, you have a type of clean room that has a non-unidirectional airflow, meaning you can have air handlers up on the roof of your room. If this is your room, I'm hoping you can see my little green thing here. If this is your room, and then up here you have your air handlers, and these are your terminal HEPA filters. So the air is going in, but there's no directional to it. It's, it can go in and come down through here. Some of it is making U-turns and swirling around. And in this type of clean room, it's going to be hard to get all your particles suspended in the air to go to be recycled out of the air or to be cleaned out of the air. This is another type of airflow where you have your end air handlers or your terminal filter is at the bottom, and the air is going on an almost upwards motion. And you can see you still have swirls around here and swirls in this side. So if you have particles suspended up here, they are going to swirl around in here and would not be washed out. So this is our clean room is unidirectional with terminal HEPA filters up in the ceiling. So this is another type of unidirectional airflow where you have your terminal filters in the horizontal position, but as you can see, the air is moving in a unidirectional fashion, and it's going in from one end and coming out through the other end. The air circulates. And the middle one is our type of clean room where you have your terminal HEPA filters up on the ceiling and air flows unidirectionally, and you have perforated tiles right here where all the particles are washed in. They go in through the subfloor, and the air is recycled back to the filters and then back to the HEPA filters. This is another type of unidirectional airflow where you have sidewall returns instead of the subfloor returns or the sidewall returns. So the air still comes in through the terminal HEPA filters up on the ceiling. It's coming down and it's recirculated, or it goes out through the side walls. So all the so looking at this slide, we may have to go back to it, because whenever you are in the clean room, you should always be aware of what you are doing in terms of the airflow. The more you disturb the air movement, and if you know that you have a laminar flow air system, you should be able to say, wait a minute, if I dance around in here, that means the air is not flowing unidirectionally anymore. And what is the result? The result is going to be turbulence. And when you have turbulence, that means all your particles suspended in the air, they are not going anywhere. Instead, they are going around in circles. And that's how you might end up um, with contamination on your devices or contamination on your tables because the air is not moving freely. So if you are doing an experiment while we are looking at this slide, I may be getting ahead of myself here, but if you are doing an experiment and you know your HEPA filters are right there above you, you either have to sit down and allow the air to go through or to pass through your process. If you hunch over, then the air is going to hit your back or the top of your head, and therefore, air around your process is going to start circulating, going around in in circles, turbulence, and therefore you end up with a contaminated product. So, one of the most important things that I always tell people is the clean room is you can be killed in the clean room. So you really have to be aware, number one, of what you're doing. Number two, make sure you do your homework, do your research. If you're going to work on A, B, C, D, do your homework because some of the stuff in the clean room can literally kill you. So one of the things that you have to do while you're in the clean room is you have to have personal protective equipment on. Always in our particular clean room, or you always have safety glasses on. The only time that you would not have safety glasses on is if you are looking through a microscope. And as soon as you finish looking through the microscope, you put your safety glasses on. You always wear 2 pairs of gloves. It's They say that the dirtiest thing you will find in a clean room is a human being. Why human beings? Because we put on makeup. So, for those of you that haven't been to the clean room and you intend on going to the clean room, please do not wear any makeup. Do not put on any heavy perfumes. I would say do not put on deodorant, but I take a stand somewhere. Hairsprays and all that stuff, the lotions that we put on our bodies, all those things emit gases that are detrimental to your process in the clean room. That's why there's a clean room protocol where you have to dress a certain way in order to minimize the amount of stuff you are bringing to the clean room that are going to be detrimental to your process. So you always have 2 pairs of gloves on because if one glove is soiled, you don't have to get out of the clean room so that you don't expose your skin to the clean room to put on a second pair of gloves. If you have 2 pairs, you can take the soiled pair of glove off without having to get out of the clean room. And then whenever it's soiled, you do the same thing. If you are working with chemicals at the fume hood or wet bench, you always have a safety shield on because most of the chemicals you are going to be working with in the clean room, they are not like your 1 molar solutions. These are concentrated solutions, concentrated that you will be working with. So you always have a face shield on. You always have an apron on, one that is chemical resistant. And on top of that, remember you have 2 gloves on. I would require you to put on rubber gloves while you're doing chemical work on a wet bench. This is all designed to make sure at the end of the day you are walking out of there without any injuries. And please note that this is on the quiz. I'm giving you a hint. The clean room garment is not protective equipment. Okay? If you spill 5 molar hydrochloric acid on that garment, it's going to go right through it. That's not personal protective equipment. Always 2 people in the clean room at one time or at any time. If you see somebody in the clean room, it doesn't matter which clean room. I don't know that many clean rooms that allow individuals, just one person, to be working in the clean room by themselves. It's a buddy system. However, the buddy system only works if you talk to the other person. If you see 2 people in the clean room, don't just go in there because, well, there are 2 people and I'll be the third one, so I'm covered. For all you know, they are leaving in less than 5 minutes after you walk in. Then you would be by yourself. So always make sure you arrange with your buddy and you talk about the time you are going to be spending in there together. If you are in our clean room and I happen to see you by yourself, that is an immediate expulsion, because a lot of things can happen and you won't have anybody calling 911 or trying to rescue you. So this is for your own safety. Always, if somebody tells you, oh, it's okay, you can be in the clean room by yourself, you really need to think hard about that. You can slip, trip, and fall, knock your head out, and nobody would know what happened to you. So always make sure you have a buddy. There are so many hazards in the clean room. I'm not trying to scare anybody. I'm just trying to give you the information so you don't just walk in without knowing. So in knowing that there are so many hazards in the clean room, you really have to come in prepared. You cannot be wearing headphones in the clean room because there are so many different sensors that are in the clean room for your safety of the equipment, that monitor gases, that monitor all kinds of things. If you're wearing headphones and something is buzzing behind the wall, you won't be able to hear it. So I always discourage anybody from wearing headphones. That way you are aware of your surroundings. Some of the hazards would be, we have, like in our clean room, we have toxic gases, we have flammable gases, corrosive gases, we have the really nasty acids and bases, we have solvents, we have high voltages. Even your broken wafers can turn into a hazard if you break it and you cut yourself, it becomes a hazard. So you really have to come in with a clear mind and watch out for what's going on. Be aware of your surroundings. That's the most thing you need to take away from this slide. Be aware of your surroundings. If something is buzzing, you don't know what it is, call your manager, call your your technician if there's a technician in your clean room. Call your professor if your professor is not around. Let them know there's something buzzing. Maybe it wasn't buzzing when you got in there, and all of a sudden you hear the noise. You have to pay attention. You also have high voltage, and always, if you have to plug something in, like a stirrer or a hot plate, before you plug it in, always make sure you inspect the power cord to make sure it's not frayed or anything. If it's frayed, do not use it. Before you use any equipment, always make sure that the equipment is running, it's in good running order, it's not under maintenance. most clean rooms do have signage that will tell you that, okay, you want to work on the PECVD. They would put in a green sign that says you can work on it because it's ready to go, or a red sign that says no, stop. Or maybe they will put on a sign that says this is under maintenance. If something breaks while you're using it, don't try and be MacGyver. Let somebody that know what they are doing fix it, because by you trying to fix something, you may end up making things worse. So always make sure you report if it's not working or it stopped working once you have started. Let somebody who knows more about that equipment know that it's not working right. They will come and assist you rather than you trying to fix something. As I always say, if you plug in a hot plate, when you're done, unplug it. A lot of things have gone on fire with hot plates that have been left running. So always make sure once you plug it in, when you're done with it, please unplug it. These are some of the gases that we have in our clean room, and I'm sure they are not specific to our clean room. Most clean rooms probably have xylene, which if it gets in contact with air, it's a spontaneous combustion, or hydrogen, which is flammable. You have nitrogen and argon, which are which will suck oxygen out of the air. But most of these gases in most places, they are contained in gas cabinets, and you have monitors. Remember how I said you always listen, always be aware of your surroundings? Some of these sensors behind the walls might be sensors sensing uh, oxygen content in the air. Or it might be if there's a leak, then you know that there's a leak because there's an alarm going on. But some of the gases like xylene, these are contained in gas cabinets and wired through orbital welding. Therefore, the idea of the gas leaking into the clean room is very minimal. It can either leak in the gas cabinet or at the tool. And once that happens, the gas cabinet will shut everything down and it will be a full blown alarm. So we generally don't ask students to deal with these kinds of nasty gases. However, most students should be able to learn how to change a normal nitrogen cylinder at least once in your clean room lives or in your lab lives. Learn how to do it. It's not hard. Ask your professor, ask your technician, ask some, can I help? They won't let you do it, but you can watch them change the nitrogen cylinder. So we don't let students do any kind of maintenance or anything like that in terms of gases. So some of your hazards do come from your chemicals, your acids, bases, and solvents. And all these are used in most clean rooms. One of the nasty acid you will use, or you may have already used it, or you may be going to be using it, is hydrofluoric acid. This is a nasty acid. You need to respect it. Make sure if you're going to be using it, the first thing you want to do before you even get to the clean room is pull out an SDS. See what it is that you're dealing with. And then once you get to the clean room, make sure you are dressed, you have your rubber gloves on, you have your rubber apron on, you have your face shield on, you are working in the proper fume hood. And if you are doing all that and you still end up with a spill of hydrofluoric acid on your skin, how I don't know, but okay, you have the spill on your skin, make sure you rinse with water. Apply calcium gluconate gel, which should never be too far from the place where anybody would be using hydrofluoric acid. Get out of the clean room with an SDS for hydrofluoric acid and go and seek medical help. In this state or in this area, the Norfolk area, I know for certain from experience that if you call 911 and tell them you have had a spill, but you can't tell them what it is that spilled on you, they will come and check on you, the fire department, ambulance, and all that. But until they have an SDS for the chemical that you are working with, they are not transporting you anywhere. So make sure, like I said before in my earlier openings, if you're working with chemicals, label your vessels. Even if you're going to be using it for only 10, 15 minutes, there's a lot that can happen in 10, 15 minutes. So always label. So once you apply calcium gluconate gel, get out of the clean room with your SDS, go to the emergency room and seek help, because exposures to hydrofluoric acid as little as 20% can be fatal. And sometimes you don't even feel the pain. You'll be like, oh yeah, I'm fine. I don't feel any pain, even though I know I spilled HF on my arm. No, go and seek medical help. Okay, this is one of the one other solvent that's generally used, the Piranha H. It's an acid 3-to-1 concentrated mixture of sulfuric acid and hydrogen peroxide. It's a self-starting reaction that's extremely exothermic. So always, if you are going to be making the Piranha H, if you are at NSU, I always tell you this to the students, if you are going to be doing the Piranha H, come and see me before you do. I'll give you more information on it before you get started. That way you don't blow yourself up, and me included, in the building. So always make sure that you are wearing the proper gear if you're going to be working with that, with the Piranha H. There's also the basic mixture. I have rarely seen it being used, ammonium hydroxide and hydrogen peroxide. This requires heat to start the reaction. But if you're working with the sulfuric acid hydrogen peroxide mixture, when you finish your rinses and all that, do not cap it, because that mixture is going to be fuming for a few more hours. Label it and leave it in the fume hood until the next day when you can safely dispose of it. All right? Always be aware of reactions that happen when you're not watching. And if you read your safety data sheets, I'm sure you'll get that information that this reaction does not finish as soon as you're done mixing it. It's going to continue fuming for a few more hours, so you don't need to cap it, otherwise it will explode. You also have your solvents, your acetone and your IPAs and your methanols. Those you need to still respect them, because they can easily inflame or they can easily burn, and you don't need to be breathing them because they can make breathing difficult. So make sure the fumes are as far away from as you can, and if you're pouring, make sure you're doing that under the hood. They are extremely flammable, so make sure all your heat sources are far from them. And if anything is splashed in your eye while you're pouring from vessel A to vessel B, there are eye wash and showers in the clean room. If you have something that is in your eye or that you splashed in your eye, make sure you flush with water for 15 minutes while you continuously have your eyes wide open. So be aware of chemical reactions that happen when you're not watching, especially those that could possibly happen while you have left them. So some chemicals are not, they don't just, you can't just say it's done. I have mixed A and B, and therefore I'm going to put this in a waste jar. You may need to hang on to it with a label on it until the following day when you can safely dispose of it. In our clean room, we don't allow students or faculty members to purchase their own cocktails or chemicals. Everything has to go through the director of the clean room to make sure whatever it is that you have to purchase is compatible with the majority of the clean room use or clean room tools. I just thought I should put that in there. Always be aware of the proper methods of disposing things. The sink is not your disposal for everything. You cannot be throwing down solvents in the sink. So in our clean room, we do have jars marked for solvents, and or you cannot be throwing acid stashed or acid wipes, acid soaked wipes in the regular trash can. No, we do have everything labeled: acid trash cans, solvent trash cans for all your solvents or your that are for disposal. And we also have the different jars of acids, because if you have to throw away an unused acid, hydrochloric acid or nitric acid, if you have 2 mils of it, you can't just throw it down the sink. You have to dilute it first, neutralization, before you throw it in the sink. However, if that mixture, if it's a mixture of nitric acid and maybe a metal, you can't throw that in the sink. So every lab or every clean room out there usually has the different vessels for disposing different things. Just because it's a waste doesn't mean it needs to all go into one big jug. Remember of the unintended chemical reactions that will happen. So make sure if you're disposing of something or you're putting it in a waste jar, it's going into the appropriate waste jar. So always, waste jars have to be always marked with the contents going into them. That way, if you have an acid jar, somebody cannot mistakenly put a solvent in it if it's clearly marked. So always make sure, if you can't tell because somebody has spilled in it, ask questions. Don't assume anything, because while you're pouring, if you're pouring in the wrong jug, that can explode right there in your face. So always be aware. That's all I'm asking for, is bring your A game. You can't be having headphones. You can't just come to wing it. This time you're actually coming to be present. If you have empty chemical bottles, if it's an acid or a base, you can rinse those and throw the water in the sink. You cannot rinse solvent bottles. If you have acetone, you have used up acetone, please do not rinse that. That's a solvent. You cannot neutralize a solvent. Another hint, it's on the quiz. So with the solvents, you leave them with the caps off so they can evaporate. Your staff members or your professors will come and collect the empty bottles. Or if you need to reuse them for something else, then your professor or the cleanroom technician, whoever the staff member is that takes care of those things will help you with that. Safe practices at the workbenches. So we talked a little bit about how you need to be, if you're working with chemicals, you need to be at a chemical workbench or fume hood. So some labs or some clean rooms do have their fume hoods in sets. You will have 2 in each area. Sometimes having 2 workbenches in the area doesn't mean that those 2 fume hoods are the same. So you need to make sure those 2 fume hoods are the same before you do your experiment or before you mix your chemicals. If you're going to be mixing corrosives, make sure the hood that you are in can actually be used for that purpose. Some clean rooms have one general hood and one corrosive hood in the same area, right next to one another. So you have to know what it is that you're doing. Is that corrosive or is that general? What's the difference? The difference is in the piping. The corrosive hood is piped by stainless steel. Stainless steel won't be corroded by any corrosives. The general hood has galvanized steel piping. So if you interchange and use corrosive fumes in the general hood with galvanized steel, that hood is gonna get the galvanized steel is gonna get etched and it will end up with holes and therefore render it ineffective for use. So always make sure what kind of hoods they are before you start your work. Do not put yourself in a position that will risk your livelihood. Do not put your face in the hood. That's never a good thing. Always make sure the sash, the little window in front of the hood, is in the closed position, which means the sash is down and your eye level is within that window. You can see through that window. And therefore, do not put your head or your face underneath or inside of the hood. Remember, you have the hood is there for a purpose. That is to suck up all the different fumes that you don't want in your face. So by sticking your head in your face and your face in the hood, that is not the way to do it. All right. You always stay behind the screen. And if you have to do one of those experiments that will go on for days and you have to leave a few beakers in the hood with your chemicals in them. Number one, those beakers have to be labeled with the contents. Number two, you have to leave some form of form to the next person coming so that they know that this is John. He left his hydrochloric acid or his Piranha H, and this is his phone number. And when the person is coming for it, you have to leave a note for the next person coming to use the area. Or maybe it's the technician. He sees the mess or you left, mess. He will probably try and clean it up. Well, if it's your experiment and you didn't leave a note, then it's going down the drain. So you need to make sure you always warn other people of what it is that you are leaving behind. And since you are in the clean room, most clean rooms don't have people, or most academic clean rooms don't have staff members coming to clean. So always make sure you clean up after yourself. Number one. Number two, also remember that you're in the clean room, and what are your contaminants? What is it that's going to contaminate your process? If you are not constantly cleaning, you are adding to the contaminants that are going to haunt you in the future, because you didn't keep your spaces clean, you didn't clean your tables. Therefore, you set down your wafer, and guess what? You just ruined your whole semester's work. So always make sure you clean. And if you're going to be using vessels, beakers, and all that, always make sure you clean it. Even though you picked it up from the dry rack, you don't know if the last person cleaned it or not. You'd never assume that, well, it was on the rack and therefore it's clean. There are some of us who are very lazy. So you need to be aware. Otherwise, if somebody didn't clean it or didn't clean it properly, they left some residue in it, and then you go and put your chemicals in it. There's already a reaction going on before you even get started with your own experiment. So always make sure you clean all your vessels. If you spill something small, you can clean it up yourself. If you spill something huge, like you just dropped a 4-gallon jug of nitric acid, remember our floors are perforated. So you have 18 inches of subfloor. That means you cannot do that all by yourself. Always make sure you call your technician and you call the staff involved to come and help you remove the tiles, and you clean the top side of the tile and the underside of the tile, and then go down in the 18 inches subfloor and clean everything from there. Always make sure you report all your spills. And if you find a spill, don't assume what it is and just go ahead and clean it. Just do a little test with pH paper just to see what it is. For all you know, it's water. But if it's acid, then you know how to clean it. We do have showers and eye wash stations, and if you spill something on yourself, you have to take that shower. Don't be modest. Remember, you are in charge of your life. Some of these chemicals are nasty, and you feel this is a good time to take a shower. Just rip those things off and take a shower. Okay? There are first aid boxes. You always, when you get into a room, like in the clean rooms, your first walk into the clean room, somebody's going to give you an orientation of that space. You need to make sure you know where all the different emergency response equipment is, your eye wash, your showers, your first aid boxes, and usually the gluconate gel is close or right there at where the corrosive hood is, because that's the only place you're going to be using it at. So it doesn't make sense for the gluconate gel to be in the storage room if you're going to be working at the corrosive hood. It has to be right there. And all the different safety equipment like your face shield, your aprons, your rubber gloves, they all should be where you need them to be. This will be a good time to ask questions, but hey, we can't do that. Anyway, so for the ladies out there, you can be pregnant while you're using the clean. It's possible. We have seen it here. We have had our grandchild here. But you have to make sure that you are just as safe as the other person. And you also have to be aware that the clean room garment doesn't come in maternity sizes. So, but you can do your clean room uh, education and be done with it and still carry your pregnancy. Um, Contact lenses. I'm not going to tell you not to wear contact lenses. That's between you and your experiment and your mentor. However, you have to know that if you're working with things that fume or that releases fumes, the fumes can be trapped between your lenses and your eyeballs. So you should be aware of that before you determine whether you want to use, you want to wear contact lenses or you just want to go and wear glasses on the day that you want to use the candle. The bottom line on safety is it's everyone's responsibility. However, you are responsible for your own safety. Do your homework. You cannot come and wing it. Maybe you did that in 101 where you worked in pairs and well, the other guy or the other girl liked chemistry more than you did, and therefore you kind of let them do all the work while you were busy, while you were the recorder of the results. This time, most projects that I've seen in clean rooms are individual projects. So make sure you do your homework. If you don't know something, don't try and wing it. We have wonderful professors everywhere in all the different universities. Their job is there to help you and they love helping you. So if you don't utilize them, that's, I don't know what to say about that one. So make sure you ask questions. Ask, ask. Do your homework and ask questions. If you don't understand, go back for the third time and ask questions. Okay? So we do have all clean rooms, I'm sure, have different alarms for different things. That's why I say do not wear headphones so you can be aware of your surroundings. Sometimes you can hear, buzzing noises, or sometimes it's a sensor that has run out of batteries. But you gotta be aware of what goes on. In our particular clean room, there's only one alarm where you have to evacuate the building. And it will enunciate, if it's a full-blown alarm, all the horns and strobes, and it will enunciate, this is an emergency, this is an emergency, please exit the clean room immediately. And when that happens, you can't be thinking about your phone or you can't be thinking about your experiment. You have to think about getting out. And when you get out, or while you're thinking about getting out, or while you're getting out, you have to know where the different exits are. Most clean rooms have different doors going to different places. You have to use doors that are marked exit. Otherwise, you'll be going around in circles. If it's an emergency and it's telling you to get out of the clean room, you don't need to dig down or go through the gowning area and take off your gown, blah, blah, blah. No. Remember, you are responsible for your own safety. So when an alarm goes, it's telling you to get out, your main focus should be getting out of there. Sometimes in different areas, like in this building, if the clean room alarm is going off, it doesn't necessarily mean that the entire building is evacuating. No. What happens in the clean room, like Vegas, stays in the clean room. The clean room has its own system. Therefore, when you get out, don't expect people to be rushing out of the building, going outside because there's an alarm going on. That just the alarm that you just heard is specifically for the clean room. However, If the building fire alarm is going off, it will evacuate everybody. You will hear it in the clean room and it will tell you to get out. If the entire building is getting out and you're wearing your clean room suit, you do the same thing. You exit all the way outside and as far away from the building as possible. I have seen people who there's a fire alarm going on, the entire building is supposed to be evacuating. They come from the 6th floor going to the 1st floor, and once they hit the 1st floor, they start kneeling in the lobby asking what's going on. It's a fire alarm, for heaven's sake. Get out of the building. All right. So we do have phones, and most clean rooms have phones, and those phones are for emergency purposes, not for you to spend Skyping or WhatsApp or any of those. It's for emergency or for talking to your professor or for calling maybe the technician or the staff is not in the clean room and you need chemicals or you need something or maybe there's an alarm or a buzzing noise coming in. That's what those phones are for. They are not for you to be sitting on and yapping all the time. Always remember that most clean rooms, there's a fee for that. For you to be in the clean room, somebody is paying. And therefore, I don't think it's a good use of anybody's money for you to go in, get charged however many, so you can sit and do nothing and just yap with your friends on the phone. All right, so we have talked about a lot of things, and like I said in one of my somewhere in between my presentation, the human being is the dirtiest thing you will find in a clean room. And in order to minimize the amount of particles or the amount of particles or the amount of junk you bring to the clean room that can be detrimental to the processes, there are some things you can do and cannot do in the clean room. There are some things you can bring or cannot bring to the clean room. For example, once you are dressed in your clean room garment, before you even get dressed in your clean room garment, you need to decide where your phone is going to be. If your phone is going to be inside your pockets, inside your gown, you have to keep it there whether it rings or not. You can't be opening your clean room garment to get your phone once it rings. If you want to take your phone into the clean room or anything outside of the clean room into the clean room, it has to go through a process where you clean it with isopropyl alcohol and get all the different contaminants that are on your phone, or if it's a chemical on your chemical that you're bringing in, you have to make sure that that is cleaned properly. If you're bringing in your laptop, it has to be wiped down with isopropyl alcohol before it can go in the clean room. You cannot bring in your regular paper and from the regular paper or notebooks. You have to use clean room paper inside the clean room. You cannot use mechanical pencils or pencils. You cannot use mechanical pens because those, the minute you use the mechanical form of it, you're generating particles. So you have to use the cheapest kind of pen you can find. You cannot bring markers to the clean room. That's detrimental to the process. If you smoke, make sure you wait at least 5-10 minutes. Drink some water before you get back to the clean room. You can't just throw away your cigarette and come into the building. You are still outgassing. If you breathe out and somebody is standing 2 feet from there, they can smell you. If they can smell you, you can contaminate the clean room. So always make sure you wait a while after your last smoke and drink some water and then come to the clean room. Most clean rooms do not have bathrooms, so make sure you get your business taken care of. If you are just starting your clean room adventure, note that it would take a good 8 to 10 minutes to gown properly. So if you don't get all your business done, that means you spend 8 minutes gowning, go inside the clean room, and then whoopsie, 45 minutes later, I gotta go to the bathroom. And then you have to, de-gown and then come back and spend another 8-10 minutes gowning. If you don't know anybody and they are knocking on the doors in order to come in, you never let anybody into any space that you don't know. So I have a little diagram here of a basic clean room gowning procedure. Each clean room has their own gowning procedure, but the end result is the same. There are like few differences, but the end result is you want to minimize the amount of particles that can be shed from that individual that is going in. So the first thing you want to do is when you go to the bathroom for the last time, make sure your hands are thoroughly cleaned. And then the first thing would be to tap once you get in. Do a few taps on the blue mat to get rid of some of the dust and underneath your shoes. We have a rubberized shoe cleaner. After you do that, you put your feet one at a time in the rubberized motorized shoe cleaner. And then after the motorized shoe cleaner, we also add another sticky mat, a white sticky mat that will lead you into the gowning area. Once you get to the gowning area, most of it is really common sense. Now you have to start off with the dirtiest part of your body, which are your shoes. So you put your shoe covers on, right? And then after that, because you want to touch different things, you put on your first pair of gloves. After you put on your first pair of gloves, you have protected your feet and you have protected your hands. Now you can use your hands to pick up the bonnet, which is the little thing you put over your head, and make sure all your hair, if you have long hair, is tucked in, because hair is still detriment to your processes. We don't want it sticking out in the clean room. So always make sure all your hair is contained. And then from there, if you have a beard, you have to put on a beard cover. If you don't have a beard, then you go to the face mask. But if you have a beard, you have to put on a beard cover, and then you have to put on a face mask. The face mask should cover your nose and your mouth. You can pinch your nose so it stays stuck on your nose. The reason we cover our nose and our mouth is because whether we like it or not, when we talk, we spit. And when you spit on your wafer, you are done with it because you just contaminated your wafer. Or if you spit in your acid mixture because you're talking to Bessie over there, then you just contaminated your mixture. So that's why you always have your mask cover your nose and your mouth, because things come out. Once you have your mask on, you go ahead and grab your gown. When you grab your gown, you unzip it, and then most places have benches. You can sit on the bench and make sure as you are wearing that gown, it does not touch the floor, because you are assuming, you have to assume that the floor is dirty, even though we know it's clean, but we want to make sure you are not picking up something from the floor. You put on your gown, you put on your hood, and then you put on your boots, you put on your safety glasses. We have a safety glass dispenser. I will tell you one thing about that. I always tell the students, I have seen maybe 2% of the students coming out of the clean room clean those safety glasses. They take them off and put them on the dispenser. So when you come in, make sure you clean the safety glasses because you are assuming nobody cleaned them. And cleaning them twice won't hurt them. So always assume they are dirty because there are some people who actually don't clean them. They just throw them in the dispenser and call it a day. So always make sure that you clean your safety glasses and put them on. And then the last thing you want to do is put on your second pair of gloves. After that, there's a mirror. Make sure everything is tucked in. Your hood is tucked in under your gown. And if you brought in anything, this is the time to hold it. Go on the sticky mat, the last sticky mat before you enter the clean room, and exit in the clean room. Once you get inside the clean room, always make sure that you are not holding the door for anybody. You walk in and have the door closed. The clean room is maintained at positive pressure. That's one of the ways we keep the clean room clean is by maintaining positive pressure. So you want to make sure we are not wasting air by keeping our doors closed. If the clean room is positive pressure, that means when you open doors, air goes out, dirty air doesn't come in. So this is it, I believe. If there are any questions, I will take questions. There is a quiz on there's a quiz that you're supposed to take after this presentation. You have until end of business day tomorrow, I believe, to take the quiz. And if you don't overthink it, you will get 100. This is mostly stuff that I've talked about and a little bit of common sense and a little bit of knowledge from back in the day or when you were doing chemistry. So make sure you take the quiz. I think you are allowed to take it twice. I'm not sure. So, and if you don't take your quiz, I think there's a consequence for that. But it's only 20 questions and maybe 1 or 2 extra credit. So make sure you take the quiz at the end.
Okay, Ms. Alice, there is another question, second question. You want to answer now?
What's the question?
Why we cannot use normal notebooks inside the clean room?
Because the regular paper that we use has fibers that will come off, and the clean room paper is specifically made not to shed particles into the clean room. Therefore, you have to use that in order to minimize the amount of particles that you'll be shedding and that are possibly detrimental to your process.
All right, so the clean room notebook is the especially designed by non-woven the paper. So
Yes.
yeah, it doesn't generate the lint.
Right. Just as much as the clean room garment itself. You can't just use any kind of garment for the clean room. It has to be specially designed so that there's no lint. Even the seams are specially made so that they don't fray. And whenever we take our garments for laundry, they have to inspect all the different seams to make sure they are still intact. And when they see frays, they remove those gowns with frays or that have soils that cannot be cleaned. They remove them from circulation and tell us and say, hey, this garment is bad, we can't use it again.
Okay, so I think you answered what happens to the gowning after it is used, right?
Actually, I can add a little bit more on
Yeah,
that.
please.
We allow students to wear the garment 5 times. 5 times does not mean 5 days. You can go in the clean room 3 times today and maybe 2 more days this week. That's 5 wears. So that garment has to be put in the laundry basket. However, if you wear it the first time and then you spill photoresist on it, you need to take that garment out of circulation or put it in the laundry basket and get a clean one, because that photoresist is now is now contaminated your garment. And for those going into the clean room, and if you are going to be wearing that garment is polyester. It doesn't breathe. So make sure if you are going to the clean room after you have taken your weekly shower and you don't put on your deodorant, you put on your deodorant but no perfumes, no makeup, no hairsprays, no lotions. Just put on a white t-shirt and a pair of jeans. A pair of jeans does not shed lint as much as a pair of wool pants. And always make sure you're not wearing high heels. You want flat-bottomed shoes.
Okay, actually there are 2 questions related to the clean room design and airflow. If I give you the details that they want to go, the one students want to see once again about the airflow process and the clean room designs, and the other student was asking about which one is better, unidirectional airflow or non-unidirectional airflow. So I think you can mix together and then answer your questions.
Okay, so let me go to the slide with the this is non-unit. You can still see my slides, right?
Yes.
Okay, so this is non-unidirectional flow. The problem with this is the idea of unidirectional is for all the suspended particles to come down with the air. As you can see with the non-unidirectional flow, you have circles around here. That generally means the air is not moving down, because the idea is for the air to move down and then recirculate, come back, get clean some more, and keep the process going. But the longer these circular motions happen, the more particles they are going to be holding in, and at some point they are going to drop. But because these particles are so tiny, you can't see them. That means they can, drop on your wafer, or they can drop on your wipe that you just put there to put your wafer, and therefore that is already contaminated. So you don't want to see these circles. You just want to see true airflow movement in these slides, even though this is horizontal, but you can see it's unidirectional, probably same speed or about same speed of the air movement. Therefore, the particles are being washed away from the air through, and then the air recirculates. And for the middle picture, this is our clean room. So you have the HEPA filters up in the ceiling. If the students were here, they would be going to the clean room, and I'll be telling them, if you look up in the ceiling, you will see light fixtures interspaced with HEPA filters. And the air is unidirectional. It moves from those HEPA filters through the perforated floors right here. And then this is the subflow is like a giant duct or giant return. That's how the air moves back up through the filters and back into the HEPA filters. So
Okay.
I believe the one with the, I'm not an expert, but the unidirectional is more conducive to what you are trying to get at if you want to get rid of particles. And for this first one, the horizontal airflow, I would think places like NASA that deal with airplane hangars probably have this type of clean room with the horizontal flow, because at the end of the day, you don't want something to impede the airflow movement. Once that happens, that's where all your particles are going to congregate and go around in vortexes. Did I answer the question?
Okay, I think we can come back later on if some other additional questions there. Okay,
Okay.
so one more question, actually two more. Well, what is the difference with the regular pencil and the mechanical pencil? Is there any difference to use inside the cleaner?
There's no difference in the sense that no pencils are allowed in the clean room. You cannot have pencils or markers. It's the composition of the pencil that one is wood, and then you have the carbon or whatever it is that's in the middle of the pencil. All those are things that shed particles, as much as cardboard box coming from wood as the parent source. So wood, cardboard boxes, plastic, anything that's not designed to go in the clean room is not good for the clean room. So if you are buying, like if you were to go into the clean room or into the gowning area, you will find that our gowns are in plastic, are wrapped in plastic. When they come back from the cleaners, they are wrapped in plastic. However, that plastic is not your normal plastic. It's plastic that is made specially for that purpose, and therefore it doesn't shed. But I cannot take the plastic that wraps around my cereal box and bring it in the clean room. That's not gonna work.
Okay, so just two questions here. Do we always have to keep the books inside the cleaner?
Can you say that one more time?
Do we always have to keep the books inside the cleaner?
Like the notebooks?
I'm not so sure, but dislikes the regular books.
No, you cannot. If the books are on regular paper, that means
regular paper. It looks regular paper.
If they are on regular paper, then the answer would be no. But if you know that you are going to go to the clean room and you want chapter 5 of that, you can copy that chapter and we can print it on clean room paper, and then you can have it in the clean room. Or if you have a recipe that you are going to try in the clean room, before you print it out, you can email a technician, your professor, or anybody that has access to clean room paper or you can get in the clean room. We do have computers and a printer with clean room paper, and print what you need out of clean room paper.
Okay, so any regular, the paper cannot be brought inside the clean room because of the particles, right?
Yes,
Okay.
right.
All right. So actually, this is another question regarding the clean room types. What are the different types of clean room again? So what kind of different types of the clean room now available?
Okay. There are many different, but I highlighted two. The first one was the ballroom design, which is one big room with everything in it. You have your equipment, and if your equipment is hooked up to the nitrogen gas cylinder, that nitrogen gas cylinder is right there in the clean room. So that would be a ballroom design. Bay and chase design is where the actual space that you are going to be doing your processes in, the one where you are counting the particles, that's the bay. And the chase is the area behind the bay or surrounding the bay, where all the support equipment for your clean room processes is. So your chillers, your gas cylinders, your gas cabinets, anything. If you ever look at the gas cylinder, it's rusted, or most gas cylinders that I've seen, they are rusted and therefore detrimental to the clean room processes. And therefore they put those in the chase. And in the chase is where the return air is. So the air from the clean room, let's say we are looking at this clean room of airflow basics. So this box represents the clean room bay. The area on the sides represent the chase. So if this is your PECVD or whatever equipment, it's hooked up to a chiller, it's hooked up to a pump, it's hooked up to oxygen, it's hooked up to nitrogen, God, it's hooked up to everything. Everything that is hooked up to this equipment is on the sides here. This is the wall, and it's on the side here. Because these cylinders and the pumps, they all outgas, they are dirty. So as air comes through the air comes from the HEPA filters, unidirectional, goes through the perforated tiles right here, and then it goes in the subfloor, and the subfloor is our return. And our return comes through here. This is where all your dirty things are, your gas cylinders, your pumps and all that. So they take out all the outgases, go through filters here, and then come back through the HEPA filters here, and the cycle continues.
Okay, I think this can be the kind of the last question, I believe. Okay, when disposing of the acids and bases, you can just use tap water, right? Or do you have to use DI water?
No, you can use tap water. We encourage you to use tap water. If it's just a plain base with nothing in it, tap water. DI is too expensive for that. So you mix with tap water and throw in the sink or dump in the sink once it's neutralized. The idea of mixing acid or base with water is to neutralize it so it doesn't react with the sewers down the line.
So answer is the yes, you can use the DI water, but it costs a lot. So.
Yeah, the best thing to do is tap water. In some areas, you don't find DI water readily available. It might just be in some labs or some clean rooms. It might be in one area, but tap water is right there. So the best thing to use is tap water.
All
And
right,
while And while you are neutralizing your acid or your base, do you put acid into water or water into acid? You guys gotta figure that one out. Do you pour water into acid or acid into water?
So it looks all the questions are answered, but actually there was one more question about the quiz. So what the structure of the quiz, how much time and attempts do we get? I think you answered this question, right?
It's 20 questions or so. There may be one for 1 credit, extra credit question, and it's multiple choice. Some are true and false, and just give me the correct answer, and everybody will be happy. This is probably one of the easiest quizzes I have done.
You know, sometimes the lecturer does say some of different way, right? Until you see the actual problem, it's not believed, right?
No, I took this one with my eyes closed. That's why I know it's easy. I took it this morning. It didn't take me 5 minutes.
Okay, so I think now the time is over. Now the over for the lecture. I believe the you got some good idea about the clean room, and then how the safety is the important, and then how you can keep your safety well. Okay, so I think you got some good. I believe you got some good idea about that. So actually now the lecture is gonna end here, and then now what you're gonna do is you're gonna move into the Blackboard. Just on me. I think several other questions are there. Okay, so you're gonna move into the Blackboard. Okay, and then you're gonna get the quizzes there. Okay, but one thing is like after the quiz. Okay, if you have additional question or something, you can don't ask answer, okay? But if you have some of some more information or some other questions, you can come back to here. Okay, we will open this for until 4. Okay. Otherwise, I will see you. We will all see you tomorrow morning at 10 a.m. again. Okay. And also, what? You will be asked to watch the videos. Okay, we already uploaded 2 videos on the Blackboard, and then actually we uploaded 2 links of the video clips. You should watch those the videos as a homework. Okay, that will help you a lot. Okay, that will help you a lot. Okay, for the tomorrow lecture. Okay. Okay, so Miss Alice, you are actually continuing some other things, or that's all?
I think that's about it.
Okay.
I'm gonna stick around just in case somebody has any questions.
Okay.
And
Right.
I believe my email address was somewhere. If somebody has more questions, then they can always email.
Okay, great. Okay, so then yeah, we will be here, and then you go all you visit the Blackboard session, and then take the quiz. Okay, we will give you the time for until the tomorrow, but yeah, try to finish as early as possible. Okay. Okay, so and then like we said that if you face any problem in the Blackboard, you let us know. Okay, we will be here to answer your questions.